Okay. We're leaving out letters. It's a one-to-one onto linear map from B to W. You know that, I think. Okay. Now, let V1 through Vn be a basis for V, W1 through Wm a basis for W. Implicitly, these are vector spaces. I didn't write it that way, but yeah, read the official formal definition in your book. We're doing more or less intuitive, but trying to be pretty rigorous about it. But I'm not going to be all that careful about writing stuff down. Okay, so. If n is greater than m, then let's call the linear map T. Okay, where is the set T of V1 through T of Vm? Where does it live?
In W.
It's in W, right? Which is what get oriented. I'm just asking a fairly trivial question, but I'm going to make sure we understand these vectors are in W. Well, then T of V1 through T of Vn can't be a basis for W. Why not?
Because it doesn't span all of W.
Because what?
Because it doesn't span all of W because n is greater than n.
Well, I think it could easily span all of W.
I mean, outside of it, the n is greater than
All you need is m vectors to span W. You've got more than m here, so it certainly could be a basis. Okay? So you got the right idea, but you got it backwards. So why can't it be a basis?
because V of n, there's more of that than, it would be bigger than.
Well, what do you know about different bases for a vector space? Well, one thing you know or should know, to be able to prove even, is that every basis has to have the same number of vectors. Okay? That's something we might want to come back and prove. Okay? So there are too many of these, and you said that intuitively, you understand that, but can we prove that more rigorously? Okay? So if we have time, we'll come back and prove this, but you should look at the proof. You should try to understand the proof. It's not a particularly difficult proof, typical thing that you need in order to kind of check out your thinking. You've got to be able to prove things to make sure you're thinking correctly. Okay? But we're proving other things here. So, so this can't be a basis, right? So, it's going to follow that this map cannot be one-to-one and onto. Okay? What does onto mean?
That it's completely inside of it.
The what?
It's completely inside of the other vector space.
Well, it's got to be completely inside, but you got the right idea and the right gesture. It's the whole vector space.
Right.
Means every vector in W is the image of some vector in V. Okay? Now, there's nothing in this that precludes that every vector in W comes from some vector in V. Okay? Might or might not. And what I just said is just totally backwards, because I was thinking, never mind. It just let me back up. Okay. And I'm not even sure what I said about onto. I've said anyhow, we see what onto means. It's a whole space. And I think I said, and then somehow transitioned my thinking, I said there's nothing here that precludes this being onto, right? Okay? You got plenty of vectors here to span the space. So this thing could span all of W. Okay? Okay. And then the map could be onto. However, the map can't be one-to-one. Okay, can we prove that? We check out whether this map is one-to-one, okay? Is it possible that the map is one-to-one? Well, let's assume that it is, okay? We can prove by contradiction. Okay, so assume and let W be some vector that's a linear combination of these. In other words, you can just pick C1 through Cn and form that linear combination. That's going to be in the space W. Okay? If it's one-to-one, then no other linear combination of these vectors can equal W. Because 1 to 1 means anything over here comes from exactly one thing over here. Okay? Onto means everything over here comes from something over here. 1 to 1 means comes from exactly one thing. And those two conditions have to be fulfilled to make an isomorphism. Okay? I'm trying to decide how to approach this. I want to write down another linear combination. What it's going to amount to is, if this is so, then you conclude that this is a basis, and you know that it isn't. Okay? So I'm going to say that if this is so, then, because I want you to think about how you might use this idea. First of all, why is it true? So I'm going to say, if so, then this is a basis for W, and our assumption is false. I want you to think about the logic of that for a minute.